Something just flew through our solar system that formed around another star. It is not from here, not from our sun, not from our neighborhood, not from anything we have ever called home. And it is doing something that, according to our best models of how the universe works, it simply should not be able to do. This is 3I Atlas, the third interstellar object ever confirmed to have entered our solar system, detected in 2025. And already it has broken something. Before we get to what it broke, we need to build the stage, because the story of how we even know interstellar objects exist is itself extraordinary. Think about what it takes for a rock to escape its home star system entirely. It forms somewhere, around some star, billions of years ago. It orbits, it collides, it gets nudged again, and then a close encounter with a gas giant, a gravitational slingshot, and it is gone, ejected, freed. Now it drifts through interstellar space. No orbit, no star, just velocity, for perhaps millions of years, perhaps billions. And then, by pure geometry, pure chance, it enters our solar system, our backyard. The first time we ever confirmed this happened was October 2017. Oumuamua. The name means scout or messenger in Hawaiian, a name chosen deliberately and wisely. Oumuamua was strange from the first measurement. It was flat, elongated like a cigar, or a pancake, depending on the model. Its brightness varied by a factor of 10 as it rotated. Nothing we had ever seen in our own solar system behaved this way. But the detail that truly unsettled astronomers was this. It was accelerating. Not decelerating as gravity should demand, accelerating, outward bound, faster than physics said it should be. No detected outgassing, no visible coma, no tail, nothing to explain the push. Avi Loeb suggested, controversially, unforgettably, that it might be a light sail, alien technology. Most astronomers disagreed, but nobody had a clean answer. Then, in 2019, the second interstellar object arrived, Borisov. Borisov was almost reassuringly normal. It looked like a comet. It behaved like a comet. It even had the same molecular signature as comets in our own system, which told us something profound. The chemistry that makes our solar system may not be unique. Water, carbon, ice. These are universal ingredients. So, one bizarre messenger, one familiar traveler, and then years of silence. Until 2025, ATLAS, the Asteroid Terrestrial Impact Last Alert System, is not designed to find interstellar visitors. It is designed to find things that might hit Earth. But on a routine survey scan, it caught something moving wrong, moving too fast, moving with a trajectory that curved back, not toward us, but from somewhere far outside. The orbital calculations took hours, and then the confirmation came. Hyperbolic trajectory. Interstellar origin, 3I Atlas, the third interstellar object ever confirmed. The designation 3I is simply the third interstellar object. The name Atlas honors the instrument that found it. Simple, clean, but what it found is anything but. Now, here is where we need to slow down, because this is the moment the story shifts from discovery to anomaly. When an object travels through interstellar space, we can work backward from its current velocity and direction to estimate where it came from. For Oumuamua, the origin traced loosely to a region near Vega. For Borisov, the path pointed toward Kruger 60, a binary star system some 13 light-years away. Plausible, believable. A gravitational encounter around a known star, an ejection event, a long journey. With 3I Atlas, astronomers traced the origin vector and found nothing. No star, no known system, just void. Now, this could simply mean the origin star has moved in the billions of years since ejection. Stars drift. The galaxy rotates. But the numbers do not quite fit that explanation cleanly. 3I Atlas is moving faster than either of its predecessors. Not slightly faster, significantly faster. And speed in interstellar travel is not just a number, it is a story. It tells you about the conditions that launched you. To be ejected at this velocity from a star system requires an extraordinarily violent gravitational event. Something massive, something close, something fast. We are talking about a close encounter with a stellar mass object, a neutron star, a rogue black hole, something with gravitational authority on a scale we rarely see. Or, and this is where the models begin to creak, 3I Atlas experienced non-gravitational acceleration, just like Oumuamua. The term non-gravitational acceleration is physics language for we measured a push and we cannot account for its source. In comets, this is usually outgassing, ice sublimating, venting, producing a tiny thrust. We can see the jets. We can model the push. For 3I Atlas, early spectroscopic data shows something, a faint signature, a coma, the suggestion of outgassing. But the velocity excess is too large to be explained by it. The numbers do not close. The model does not balance. Something is missing from the equation. Let us sit with that for a moment. Because this is what science actually looks like at its frontier. Not triumphant answers, but equations that refuse to close. There is a second anomaly, perhaps more philosophically unsettling than the first. When astronomers analyze the composition of 3I Atlas, the molecules it is shedding as it warms near our sun, they find a ratio of compounds that does not match our solar system's comet population. Not dramatically different, not alien bizarre, but different enough to matter. The ratio of carbon monoxide to water ice is elevated, more CO than we typically see in our comets, and that points toward a colder origin, a star system further from its sun than ours, a colder protoplanetary disk, a place where even carbon monoxide, which sublimes easily, could freeze into the nucleus. This means 3I Atlas carries within its frozen interior a chemical record of a star system we have never visited, a snapshot of chemistry from another sun. Think of it the way geologists think of ice cores drilled from Antarctic glaciers, except instead of 10,000 years of climate history, this ice holds billions of years of another world's formation. Every molecule venting from this object as it heats up near our sun, every jet, every puff of gas, is a message from a dead or distant solar system we will never reach. We are reading that message right now, in real time, from the ground, from orbit, from every telescope we can point at it. The James Webb Space Telescope has been allocated observation time for 3I Atlas. What Webb sees will be unlike anything it has studied before. Webb's infrared sensitivity means it can read molecular fingerprints at a resolution no ground telescope can match. If there are complex organics in that coma, amino acid precursors perhaps, Webb may find them. And complex organics would mean this: the building blocks of life, or something life-adjacent, are being exchanged between star systems passively, constantly, across cosmic time. This is panspermia, the idea that life's ingredients, or perhaps life itself, could travel between stars, not as science fiction, as measured chemistry. We are not saying there is life on 3I Atlas. We are saying it may carry the raw materials that, under the right conditions, could have become life somewhere else. Now, let us return to the anomaly that started all of this, the impossible motion. 3 competing explanations are currently on the table among researchers, and they are not equally comfortable. Explanation 1: enhanced outgassing from an unusually volatile composition. The CO and nitrogen ices may be generating more thrust than standard models predict. This is the conservative answer, the boring answer. But boring answers are often correct, and we should not dismiss them simply because they lack drama. Explanation 2: 3I Atlas was ejected from a stellar environment we do not have in our galaxy catalogue, perhaps from a dwarf galaxy structure or a globular cluster where stellar densities and velocities operate at a different scale entirely. In a globular cluster, stars are so tightly packed that gravitational interactions between systems are common events, not rare ones. An ejection event that could easily produce the velocities we are measuring. And a globular cluster origin would also explain why the backtraced trajectory points to empty sky. The cluster is moving. Explanation 3 is the one nobody is comfortable saying out loud in formal papers, but which keeps appearing in the footnotes of conference talks, that the non-gravitational acceleration cannot be fully explained by any known natural process, that we are missing something fundamental about how objects behave across interstellar distances. Not aliens, not technology, not a signal, simply a gap in our physics, a behavior our models cannot account for. And if that is true, even partially, then 3I Atlas is not just a rock from another star. It is a stress test of our entire framework for understanding motion through deep space. Here is what I want you to sit with, not as a physics puzzle, as a question about what it means to be aware inside this universe. This object has been traveling alone through interstellar space, possibly for longer than the Earth has existed. There was no one to observe it, no gravity to hold it, no light but the faint background glow of distant galaxies. And then, by the most extraordinary cosmic coincidence, it entered the only solar system in which creatures have developed the tools to notice it, measure it, and wonder about it. That is not mystical. That is just what it is. But it should feel significant, because this is the central philosophical question that 3i Atlas is quietly asking us. What kind of universe permits this? A universe where material, chemistry, structure, perhaps even biological potential flows between star systems. Not through intention, but through pure physical law. Gravity does not care about destination. Neither does momentum. Objects are ejected, they travel, they arrive. The galaxy is porous. If 3i Atlas carries complex organics, confirmed or even suspected, then the boundary between our solar system and elsewhere becomes philosophically meaningless. We are not an island. We never were. We are one node in a slow, vast, mindless network of exchange that has been operating since the galaxy formed. And the atoms in your body, the carbon, the oxygen, the iron in your blood, they too were once somewhere else. In another star, in another cloud. 3i Atlas is not a visitor. It is a reminder. It is the universe demonstrating again that the walls between worlds are thinner than we imagined. Now, let us think about what comes next for this object, because 3i Atlas will not stay. It is already leaving. Its hyperbolic path means no gravity can hold it. It came too fast. It will leave too fast. Our sun cannot capture it. In months, not years, it will be beyond the reach of any instrument we currently operate. The window for observation is closing now. There are proposals, serious, funded adjacent proposals, to send a spacecraft to intercept 3i Atlas before it leaves. The intercept window is short, the engineering challenge is enormous. But if we could get even a flyby, even a single instrument reading from close range, we would have a direct sample analysis from another star system, without leaving our own. That prospect, a near-term, realistically achievable interstellar sample mission, is not science fiction. It is an engineering problem, and engineering problems we know how to solve. What 3i Atlas leaves us with, beyond the anomaly, beyond the chemistry, beyond the philosophy, is a new understanding of how science should feel. It should feel like this: incomplete, urgent, alive. The models do not close. The origin is unresolved. The velocity excess is unexplained. And every telescope we have is watching. Because in science, an open question is not a failure. It is an invitation. 3i Atlas came from somewhere we cannot see, moved in ways we cannot fully explain, and carried chemistry we are only beginning to read. And it asks us, in the only language physics speaks, whether we are paying attention. We are. And the answer it gives us, whatever that answer turns out to be, will change how we think about our place in a galaxy that is far more connected than we knew. If this kind of thinking, the kind that refuses to stop at the discovery headline and asks what it means to be conscious inside a universe like this, if that is what you come here for, then subscribe. New videos every week. The universe keeps surprising us. We will keep following it.